Welcome back, ladies and gents. So we're going to start a couple algebra concepts that usually are kind of difficult for students, but we're going to kind of just touch base on them so that way when you see them in algebra they're not so confusing. So your warm-up is just what is the square root of 64? Now remember, the square root symbol looks like this. It's called a radical, okay? This is a radical, okay? And radicals, or the square root, is the opposite of squaring, right? So we know that 2 squared is 4, and 3 squared is 9, and 4 squared is 16. So when you take the square root of 4, you're left with 2. When you take the square root of 9, you're left with 3. When you take the square root of 16, you're left with 4. Okay, hopefully you've seen this once or twice before. But in general, when you take a square root, you want to find the number, or the two numbers that multiply together that are exactly the same number that equal the number inside the radical. Okay? And when we get pretty numbers, like a whole number out, those are called perfect squares. Okay? So 1. Well, 1 is equal to 1 times 1, right? There's 2 of them, so I can pull 1 out. So the square root of 1 is just 1, because 1 times 1 equals 1. 4 is 2 times 2, right? 2 of them, I can pull 1 out. Square root of 4 is 2, which we've talked about this one already just a few minutes ago. 9 is 3 times 3, so 2 numbers exactly the same. Okay, it's 3. 16 is 4 times 4, so the square root of 16 is 4. 25 is 5 times 5, so the square root of 25 is 5. The square root of 36 is 6 times 6, which is 36. Okay, and 49 is 7 times 7, so I get a, I'm sorry, this is supposed to be a 6. Woo, sorry guys. The square root of 36 is 6. The square root of 49 is 7. Get a little excited there. Okay, so as you notice, I had 2 numbers inside each one, and that came out to be one of them. I had 2 on the inside, 1 came out, 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 2 on the inside, 1 came out. Okay, so that's going to be kind of the general rule we follow, because 1, 4, 9, 16, 25, 36, and 49 are all what we call perfect squares, because when I take the square root, a nice pretty whole number comes out, okay? There are definitely more perfect squares. You know, you can keep going to, 8 squared, which is 64, 9 squared, which is 81, so on and so forth. There's plenty more, but these are the main ones we're going to deal with for the next couple days, okay? So the reason you pulled, my trick to remember this is 2 buddies, you can pull 1 out, because there's actually an invisible 2 sitting on all of these square roots, but we don't write it when it's a square root because it's just assumed. But later you can get into cube roots and 4th roots and 5th roots, okay? So all of that comes later though, okay? All right, so let's try some examples that are not perfect squares and see what we do with them, okay? So 8. 8 is not a perfect square, right? It's not on my list. So I'm going to separate these into 2 numbers, and I'm actually going to write the square root of 8 a little bit bigger so you guys can see it. So 8, I'm going to think of 2 numbers that multiply to be 8. So I'm going to make my prime factor tree, okay, which we did towards the beginning of the year. So 8 is 4 times 2, right? Well, 4 is 2 times 2. So all my prime numbers are 2 times 2 times 2. Well, 2 of them means I can pull 1 outside of the radical. So that means there's a 2 on the outside, and I'm left with this 2 here because he does not have a buddy to get out with, so he just has to stay under the radical. So 2 square roots of 2. Okay? And 4 you could also think of as a perfect square. The square root of 4 is 2, so I can pull that out. Okay? Whoops, sorry guys. My setup here isn't as good today. Alright. So now let's do the square root of 12. I'm just going to make this bigger here. So 2 numbers that go into 12 are 4 and 3. 3 is prime. 4 is 2 times 2. Okay, and those are all prime numbers, so I'm done. So again, I have 2 2's, so I can pull that one guy out here. So I have a 2 on the outside and 3 on the inside. Bam, bam, you're done. That's a simplified radical. So this is calling simplifying radicals, okay? So it's pretty easy once you get the hang of it. You just got to really practice it, okay? I got a couple more for you. So square root of 18. Again, I'm going to just break it down. 18 is 9 times 2. 2 is prime, so I'm going to circle it. 9 is 3 times 3. I have 2 buddies, and pull one of them out. So on the outside of the radical is a 3, and since the 2 is alone here, I have to leave it inside the radical. Again with 27, 27 is 9 times 3, and 9 is 3 times 3, so these are all my prime numbers. 2 3s, can pull one out. So there's a 3 on the outside, and this 3 does not have a buddy, so he has to stay on the inside. Okay. Now sometimes when you break it down, you're not sure if a perfect square goes into them. So if you notice each of these, I knew that 9 was a perfect square that went into 27. 9 was a perfect square that went into 18. 4 was a perfect square that went into 8. 4 was a perfect square that went into 12. Oops, sorry, you can see 4 goes into 12. So it's nice, kind of hint, look for a perfect square 1, 4, 9, 16, 25 to see if it goes into it. But if you don't know, like 98 on the top of my head, I don't know what perfect square goes in, you know. I mean, I could probably think about it if I sat here for a while, but it's not going to come right away. So what I'm going to do is just, I know 98 is an even number, so I'm going to say, well, it's 2 times 98 divided by 2 is 49. And now I can see the perfect square. So 2 is here, 7 times 7, right? And again, same idea, just bigger numbers here. 7 is going to go on the outside because it has a buddy. And just one of the 7s goes out, not both of them, and then they both disappear inside the radical. And a 2 on the outside. Okay. Again, 48. I know 4 goes into that, right? So 4. And 4 times 12 gives me that. Well, 4 is 2 times 2. Now, 12 is 4 times 3. 3 is prime, and 4 breaks down into 2 times 2. So now this one's a little different because now I have a set of 2 guys here that's coming out. Another set of 2 that's coming out. Okay, and then my 3 is left inside. So I have 2 times 2 on the outside because I'm pulling both sets out, square root of 3 because 3 is by itself. And then 2 times 2 on the outside is actually 4. Okay. Nice job. Okay. So sometimes you'll have to pull out more than one number and you multiply them on the inside. If you had 2 numbers, like let's say there had been like a 2 outside here or left, you would have multiplied those on the inside of the radical. Okay, let's try 250. So I know this is 10 times 25. So 10 is 5 times 2. 25 is 5 times 5. Okay, again I have these 2 5s. I can pull one of them out. So 5 square roots of 5 times 2, because that's what's left here. And 5 times 2 is just 10, so I multiply them on the inside. So if things are left over on the inside, you just multiply them back together again, okay? Alright, last one, 72. I'm going to have you guys try it, see what you can do, and have a wonderful day. We'll talk to you tomorrow. Bye.